Today we're looking at section 4.5/4.6. Both of these sections have to do with factoring polynomials. So our objective today is I can factor polynomials. To factor polynomials, there are several steps that we have to go through. So step number one is to look for common factors. So for instance, example 1, if I have 3x cubed minus 15x squared, both terms, this term and this term, both of them have a factor of 3, and both of them have a factor of x squared. So we factor that out, and then inside the parenthesis, for the first term, we have left just an x, minus, and in the second term, if we take out a 3 and an x squared, that leaves us a 5. Then we look inside the parenthesis, and that won't factor any further. Okay. Another type of common factor might look like this: 5 times x plus y minus 4 times x plus y. Well, remember, if something's in parentheses, we treat it like a single number. So there's two terms here. Here's one term, here's the second term. They both have a common factor of x plus y, so we factor that out. And what's left is a 5 minus 4. Or we can simplify that to just 1. So x plus y times 1. Right? So any time you're factoring, the very first step is to look for common factors. Then once you've found the common factors, the next step is to determine how many terms. How many terms the polynomial has. Okay, so for instance, if it has two terms, okay, if it has two terms, then we look for what are called special products. So we look for 1, is it in the form a squared minus b squared, which always factors to a plus b, a minus b. So for instance, example, y squared minus 49. Okay, well that is, it has two terms. First step, there's no common factor. Second step, it has two terms, and so that can be written as y squared minus 7 squared. So it's in the form a squared minus b squared. So that will always factor to a plus, or y plus 7 and y minus 7. Okay. Another example would be x cubed minus x. Step number 1, look for common factors. There's a common factor of x. Then I have x squared minus 1. I have two terms. There's two terms, so I ask myself, could that be the form a squared minus b squared? So can this be written as x squared minus 1 squared? And yes, it can. So then I factor that to x plus 1, x minus 1. Right? And example 3. We have something like this: x to the 4th minus 16. So there's no common factor, so then there's two terms. So I ask myself, could that be written as a squared minus b squared? And yes, this could be written as x squared squared minus 4 squared. So then that's going to factor to x squared plus 4 x squared minus 4. Now you have to be careful because notice that this one is also in the form a squared minus b squared. So you have to factor further. So the first one cannot be factored further, but this is x plus 2, x minus 2. Okay? Now, the other possibility, if there are two terms, is could it be sum or difference of cubes? Okay, so sum or difference of cubes, we're looking at something like this. A cubed plus b cubed, or a cubed minus b cubed. Now, these always factor to a specific formula, and you have to memorize this formula. A cubed plus b cubed will always factor to a plus b times a squared minus ab plus b squared. And that's as far as it will factor. And again, it's just a formula, you have to memorize it. A cubed minus b cubed will always factor to a minus b, and then a squared plus ab plus b squared. So an example of this one would be something like this. If I have a 2a cubed plus 16. Step number 1 is look for a common factor. There's a common factor of 2. Step number 2, how many terms are there? Well, there's 2 terms. It's definitely not going to be difference of squares because you see this is a cube. So then you ask yourself, could 8 be written as some number cubed? And yes, it can. It can be written as 2 cubed. Okay, so then that's going to factor to 2 times a plus 2 times a squared minus 2 times a plus 2 squared. And that would be our final answer then. Okay. Example 2. If I had x cubed minus 27, so there's no common factor, so then I go on, there's 2 terms, and I see that this is a cube, so then I ask myself, could the 27 be written as something cubed? And yes, it can. 27 is the same thing as 3 cubed. Oops. So then that is difference of cubes, so that's going to factor to x minus 3. Notice it's just exactly the things that are being cubed. Then it's the first thing squared plus these 2 multiplied together, just the x and the 3, plus the last one squared. Right? And then that is going to be our final answer. That is completely factored. It cannot be factored any further. All right, now another possibility is that we have 3 terms. Oops. Let's see, this is, 3 terms. All right, so it could be something that looks like this. Example. X squared minus 5x plus 6. All right? Well, what we do then is we make a little x, and we put the constant on the top, and we put the coefficient of the x on the bottom. Then we ask ourselves, what 2 numbers multiply to 6 but add up to a negative 5? So that's going to be negative 2 times negative 3. Negative 2 times negative 3 is a positive 6, and negative 2 plus negative 3 is a negative 5. So then those are our factors. So this will factor to two binomials, x minus 2 and x minus 3. That is our final answer. That is completely factored at this point. Okay. Example 2. If I have m squared minus 2m minus 35. So again, I take the constant and I take the sign in front of it, so it's a negative 35, and I take the coefficient of the m, and I ask myself what multiplies to 35 but adds up to a negative 2. And again, it's a negative 35, so it's going to be a negative 7 and a positive 5. Negative 7 times positive 5 is a negative 35, and negative 7 plus 5 is a negative 2. Okay, so then I'm going to have two binomials, m minus 7 and m plus 5. And again, if you multiply that out, you'll see that it multiplies out to exactly m squared minus 2m minus 35. Okay, example 3. If I have y squared minus 14y plus 13. So again, I put the positive 13 up here, the negative 14 here. So what multiplies to a positive 13 but adds up to a negative 14? And that's going to be negative 13 and negative 1. Negative 13 times negative 1 is a positive 13. So we have this. And negative 13 plus negative 1 is a negative 14. So this is going to be y minus 13 and y minus 1. Right. And there are some like this one. Let's look at this one. Y squared plus 3y plus 4. So I need something that multiplies to a positive 4 but adds up to a positive 3. Well, the only factors of 4 are 4 times 1 and 2 times 2. Neither one of those add up to a positive 3. So this one does not factor, and we would say that it is prime. Right. Then the last situation that we might have is that there are 4 terms. In the polynomial. All right, so that might be something like this. We have 3xy minus 4 minus 6x plus 2y. All right? Now, what we want to do is we want to group 2 terms together so that they have a common factor. So in this case, I might rewrite this as 3xy minus 6x, because I noticed that this term and this term both have a factor of 3 and a factor of x. And then I might have plus 2y minus 4. Then this is called factoring by grouping, because now what I'm going to do is I'm going to group 2 terms together. So I'm going to take 3xy minus 6x, put those in parentheses, put a plus between them, and then have 2y minus 4. Then in the first parenthesis, is there a common factor? And there's a common factor of 3x. So if I factor out that 3x, it leaves me a y minus 2. In this parenthesis, is there a common factor? And there is. It's a 2, so I factor out the 2. And then I see, remember, if it's in parentheses, we treat it like it's a single number. Now I see that I have a common factor of y minus 2. So I factor that out,